Let's look at a few of the web-assigned homework problems that I suspect that if we were meeting in class, people would have a question about. The first one, we're supposed to state whether this is true or false. Check this antiderivative, this indefinite integral, by differentiating. So, is this statement true or false? What we want to do is to differentiate the right-hand side and see if we get this function, which we call the integrand. We call this function the integrand. We're doing anti-differentiation, sometimes called indefinite integration. We call this what you're taking the antiderivative of, the integrand. Okay, so let's take the derivative. Okay, constant multiple rule, the negative 9 can come out front. Derivative of a constant is 0. Now, I'm going to need a quotient rule. So that's the bottom times the derivative of the top. I'm going to write my road map. Minus the top times the derivative of the bottom, but the bottom is just x, so I know that's 1 all over bottom squared. Take a look at that much and see if you agree. Use constant multiple rule to pull the 9 out in front. Then I used quotient rule. Now, I'm not finished differentiating, however, because I've got to take the derivative of 1 plus x squared to the 1/2. Well, that's a power, so I use power rule. I'm differentiating, so I subtract 1. But remember, I have to use chain rule because I have an inside function. The 1 plus x squared is an inside function. So I've got to multiply by the derivative of the inside. That's 2x. Anything times 1 is that thing. Okay? This turns out nicely because notice I have a 1/2 here. And I've got a 2. 1/2 times 2 is 1. But I also have an x and an x. X times x is x squared. But that's times 1 plus x squared to the negative 1/2. So I can divide by 1 plus x squared to the positive 1/2. Remember, the negative exponent just means take the reciprocal. Okay, I'll copy down this second term. And this is all divided by x squared. Now, it's helpful to look back and see what I'm trying to get. I'm trying to get 9, or I'm trying to get close enough to this so that I can see if this is right or wrong, to see if the answer is true or false. But I've got 9 over x squared, square root of 1 plus x squared. If this is going to be a true statement, this is what I've got to end up with. Notice it's just a numerator and a denominator. There's not a fraction within a fraction. But look at what I've got here. I've got a fraction within a fraction. So let's multiply by 1. So let's multiply by the same thing in top and bottom to get rid of that complex fraction. The denominator here is 1 plus x squared to the 1/2. Okay, the denominator in the numerator is 1 plus x squared to the 1/2. So I'll multiply by that over itself. That's legal because I'm multiplying by 1. Now, in the bottom, what's that going to give me? It's going to give me x squared times 1 plus x squared to the 1/2. But in the top, I have to distribute this 1 plus x squared to the 1/2 across this subtraction sign. When I multiply 1 plus x squared to the 1/2 by this first term, x squared over 1 plus x squared to the 1/2, those 1 plus x squareds to the 1/2 cancel, and I just get x squared. Minus, these parentheses are very important, 1 plus x squared to the 1/2 times 1 plus x squared to the 1/2 is just 1 plus x squared. The square root of something times itself is just that something. Okay, x squared minus 1 minus x squared. You remove the parentheses, change the signs, so the x squareds go away, and I'm left with minus 1. And in the bottom, I've got x squared times 1 plus x squared to the 1/2. So I get 9 divided by x squared times the square root of 1 plus x squared. And lo and behold, that is what I wanted to get, right? So this is true. Because this matches this. Okay. Make sure you realize you can know if you're right or wrong on every single anti-differentiation problem just by differentiating the result and see if you get the original integrand. Now, number 5 isn't hard to anti-differentiate. Cosine x plus 1/9 x. I think you probably all got sine x plus 1 over 18 x squared plus c. But then they have a bunch of graphs. And there are a bunch of graphs, and maybe there's 5 graphs in each choice, A, B, C, D, E, and they're all parallel. Why are those graphs all parallel? Because they all differ by a constant. The function graph is always in those choices that they picture, A, B, C, D, and E, sine x plus 1 over 18 x squared plus 0 or plus 5 or plus 10. So the height of those graphs is going to differ by a constant. How can you pick out which graph? Well, what I would do is I'd just let C be something that if you look at their choices, that they've let C be. In their choices, it looks like, if you look in WebAssign, that they've let C be -5, 0, 5, 10. Let's just let C be 0. Well, if you let this C be 0, you get sine x plus 1 over 18 x squared. Well, if you graph that on your graphing calculator, you can see the graph, and you can see which of the choices, A, B, C, D, contains exactly that graph. So that's how I would pick the right graph. Okay, finally, number 7. You've got to do some algebra first. Rewrite this as 5 over x dx plus square root of x over x dx plus x over x. Just doing algebra. Now, this 5 can come out in front of the antiderivative symbol. I can rewrite this x square root of x as x to the 1/2. That's divided by x, or x to the first. X over x is 1. I have not done any calculus here whatsoever. I have just done algebra. Okay. Most general antiderivative of 1 over x is natural log absolute value of x plus c. But all these 3 terms are going to have a plus c, so I'll just combine those plus c's and write the plus c at the end. This is plus the antiderivative of x to the negative 1/2. Be careful here, I didn't do any calculus. I've still got this integral sign here. X to the 1/2 divided by x is x to the negative 1/2. I just simplified with algebra. Antiderivative of 1 is x. Now let me caution you. Notice I do have an antiderivative sign left here. That's because I've not yet taken the antiderivative. But on this first term and on the last term, I don't write the antiderivative sign because I've already taken the antiderivative. Make sure your notation here is correct. So I get 5 natural log absolute value of x plus the antiderivative of x to the negative 1/2 is x to the positive 1/2. Notice I just used power rule for antiderivatives. I added 1, and I divide by that exponent. So I can write my final answer as 5 times natural log absolute value of x plus 2 times square root of x plus x plus a constant. When you divide by half, you multiply by 2.